Hello, everyone. Today we're going to take a look at the difference between correlation and causation. This is a very important concept to keep the distinction between the two terms separated. I'm going to share over my screen so we can discuss this further. Okay, so in section 5.1 of Statiplus, we defined the x values to be the independent variables and the y values to be the dependent variables. So with this, it seems to say that we're saying that the values of y depend on the values of x. And this is often how we are taught to think of functions in early math courses in junior high and high school. And so it is important to realize, though, that at this point in our studies, we don't necessarily have any way of justifying that one variable causes or depends on the other one. And it's made clear in this little red blurb here, but we're going to follow it through a little bit more going forward. In 5.3.1, we did define Pearson's correlation coefficient, or simply the correlation, to be the R value given by this somewhat awkward and nasty formula. We looked at some different properties of it. It's always between -1 and 1. If the absolute value is 1, i.e. if it's -1 or +1, the values are perfectly collinear and it's symmetric. So x and y can freely switch. So even at this stage, we can see there's no real bias towards x or y. We eventually developed what we call the least squares regression line, excuse me, or something there in regression. We saw this formula here, and some people are taken back by the variables or the constants shown here, which is mentioned in the remark. But just to be very clear, correlation does not imply causation. There are a myriad of examples of variables that are correlated but not have any causation between them. Excuse me. This is nicely illustrated, I believe, by an XKCD comic. I'm just going to show it on the screen here briefly. I'll let you pause if you want to read it, but it's a very good joke if you can understand the difference between the two things. One example of the type of things that this can lead into is the thing that became famous a little over a decade ago now, that there was a scientific paper which proved a link between eating chocolate and weight loss. And this article, currently being shown by CBS News, journaled the way that this was done in a way to fool or show the non-scientific literacy of mainstream media. Even websites like prevention.com, posted it as a factual true story. Now, as you can see on this link here, they do have an editor's note that this website did do a sort of retraction. They did what I believe is good journalism, where they did not simply delete the article like many other places did. They left it up, but simply said, we now acknowledge this was a mistake. As they say, they regret the error. So this is simply to show that bad research does exist. And it's one of the reasons we want to be critical consumers when we're looking at statistics. Another website that offers some interesting things is one by Tyler Vegan. This looks at other spurious correlations, and this is right there at the top of the page. Correlation is not causation. So here we see the relation between the variables annual U.S. household spending on fresh fruits and how it correlates with Canadian National Railway Company's stock price. Now, this is shown a different way than we're often seeing. If I want to look at the scatter plot, I can click here. This gives me an R value of 0.986 and R squared of 97.2%, which is a pretty good coefficient of determination. Now, you can scroll and see many other examples here, and in each one you can click on to see the scatter plot. Click on a couple of them to show them to you. One I found most interesting for our class is this one. This one is the bachelor's degree awarded in mathematics statistics as it correlates with Google searches for tummy ache. We get an R squared value of 98.3%, which we will soon realize means that it appears that knowing the number of bachelor's degree awarded in math and statistics can improve your guess about the number of Google searches for tummy ache by 98.3%. Now, I believe it's clear there's no real reason that the black variable, the degrees awarded, would impact or give you a value for the red variable. But this website is nice and uses a fun use of AI to actually give a funny reason for why this may be true. And in fact, also gives a mock paper that goes through and discusses how this can be shown as what's going on between math and stats degrees and tummy aches. Um, so this is an example of where we simply have looked at so many data sets that we found a link. In this example, you can go into Tyler's website and he simply says he pulls from, I believe it's hundreds of thousands of data sets and looks for ones that simply correlate. He's not saying that anything is causing the other one. He's simply showing that if you look at enough data sets, you'll find high correlation, which is the basis behind what happened with the chocolate um, study being shown. They followed reasonably solid clinical procedures, but they simply looked for any positive attribute that was associated or correlated with people having an increased amount of chocolate in their diet. If 13 of the markers went down, but one went up, they're only going to report on the one that went up. So we had, I should say, in a positive direction. So weight went down, they took that as a positive. Other examples of this where they actually do have a different sort of linkage and it's not completely random, is the idea of confounding variables. This is mentioned in our textbook as well. Go back to that. I think I have an example down here. I apologize for the scrolling on you. Yeah, here it is, an example 5.9. I'll discuss a different one out loud here. A classic example is, let me turn off the search for a second. So, classic example of this, what I recall back from a book I read years ago, was that there is a strong correlation between the number of fire trucks sent to an emergency and the financial damage done to a home that's being responded to. So, if you were to believe that correlation implies causation, it'd be seeming to show that if you want to prevent financial loss at a home, you should send less fire trucks. The issue is that there's a missing or lurking or confounding variable here, which is the size of the fire. If the fire is large, we send a lot of trucks. We also expect to have a large amount of financial damage. It's not really the number of trucks causing damage, it's the underlying variable of the size of the fire. So this is a quick little video with an unfortunately raspy throat today to discuss the difference between causation and correlation. If you have any questions, please feel to reach out. Thank you very much.